Hey guys, I hope that I'm live right now. If you guys are able to listen me properly as well as there's no issues with the audio or the video, could you guys please let me know? Hello everyone, I hope that I'm live right now guys. If you guys are able to listen me properly as well as there's no issues with the audio or the video, could you guys let me know once? Hello everyone. I hope that I'm live right now, guys. If you guys are able to listen me properly as well as there's no issues with the audio or the video, could you guys let me know once? Yes, everybody is able to listen me properly, right? Okay. So today we are going to learn about a new concept called as pointers. For those who have already studied it in previous, maybe you guys have learned it in some previous class, or maybe you have studied some other languages, maybe you have already studied C++. So you might be able to understand that pointers are a little bit difficult concept to encapsulate within your head. But when it comes to arrays, it is a major concept and it is very important for us to understand what are pointers and how to use them. That is what we will be starting out with our today's class. Okay, will that be fine with everybody? Please let me know. Lavia, I will make sure that I'm able to send you the message today itself. I'm very sorry, Lavia, I was not able to do that. I'll do it today itself. Okay. Yes, guys, like I said, today we will be starting out with pointers. Before we are able to do that, can we do a quick revision about what we have studied in our previous classes? Can we do a very quick revision about what we have studied in our previous class, guys? What we studied yesterday? Could you guys let me know? Just a quick revision, guys. What we have studied in our previous class, that is yesterday. Could you guys please let me know? We started out with arrays, right? What did we study in arrays, guys? What did we study in arrays yesterday? What did we study in array, guys? What did we study in array? Inserting an array, printing using groups, that is traversing of array, inputs of an array, okay, creation of an array, okay, okay, array implementations, good, traversing an array, array size, array length, good. Okay, so that is what we studied in our yesterday's class, and today we'll start out with pointers. Now, yesterday we talked about the size of an array. Do you guys remember the formula of calculating what is the size of an array, guys? Do you guys remember the formula of how to find out the size of an array? Could you guys please let me know? Do you guys remember that formula, guys? Ara, could you guys please let me know the size of function, right? Size of the array divided by the size of the element gives us the size of the means the number of elements present in the array. That is what we saw yesterday. Now, if you guys remember, when we use the particular size of the array, the first element in the array that was an integer, we got the answer as 4 bytes, right? 4 bytes. Now, how is this actually, how is this getting saved inside of our computer? We need to understand that. The computer has multiple different places where it actually stores numbers. Okay. For example, you are having your SSD or HDD, your hard disk or your SSD if you are using at any particular point of time that is of 1 TB or 512 GBs or something like that. Now, these are external drives. These are the slowest and the most cheapest form of memory available for your computer. Then comes up the RAM. Okay. So many of you guys must have heard that, okay, my computer has 4 GBs of RAM, my phone has 8 GBs of RAM, my computer has 12 GBs of RAM or 16 gigs of RAM as well. Now, these are the second fastest memory that is available to your computer, as well as very costly as well. If you compare it, a 16 gigs RAM will cost you the exact same as a 1 TB HDD or a 1 TB SSD for the fact as well. These are very costly. the most fastest memory that is actually available to your computer is actually something called as the cache memory, or the L1 and L2 memory, that is available alongside your CPU. So your CPU also has its very own memory. Now this memory is the fastest and the most costliest out of them. This memory within computers is usually between 1 to 2 MBs, or just 1 to 2 megabytes. And it costs the exact same as 1 terabyte of an SSD. So you can think how costly that cache memory is. Now, whatever elements that you're creating actually get stored inside of your RAM first. Okay, we'll try to understand how this happens. Okay, let's try to understand how this happens, guys. Let me open up a note right over here. Let's try to understand this, guys. It will be super simple, guys. Do just make sure that you guys are paying attention in the class. You will be able to understand. It's a very important concept to understand. That is the only reason why I'm teaching you guys this. Because for me, it is also important that within the interviews, if some questions are coming to you guys are actually able to solve them, rather than looking at the interviewer's face like, what are you even asking? Okay, I don't want that. Right? I want you guys to be able to answer most of the questions that the interviewer is going to ask you guys. Okay, so let's get started with it. So whenever you create a particular element, let's just assume I'm creating int a is equals to 4. So I am creating a variable called as a, which contains a value 4 inside of it. Now where is it actually stored inside of the memory? Usually this will be stored inside of your RAM. Okay, it will be stored inside of your RAM, guys. Now whenever your computer actually needs to use this, for example, if you're writing a plus uh, 4, b is equals to a plus 4 or something like that, okay, or a is equals to a plus 4, if you're doing any arithmetic, what is going to happen is from this RAM the stuff is going to be pulled into your cache, and this is where your complications, your mathematics will be happening. This cache is usually present with your CPU, guys. Okay, it is integrated in most of the cases. Your cache and your CPU are integrated together so that they are able to communicate on a faster note itself. Now leaving that all apart, okay, can we buy cache memory? Of course, yes, but you cannot increase your cache memory. If you meant that okay, I am having a cache memory, can I increase it? So you can't. The only way of doing that is to basically change your entire processor. So you can upgrade it into the latest processor, which will have a lot more cache and a lot more computational power itself. But yes, you cannot increase your cache normally, just like you do with RAM or SSD itself. Leaving that apart, guys, so like I said, int a is equals to 4. So inside of your computer, a particular area will be created which will store this 4 inside of it. The amount of space that this particular area will take up will be equal to 4 bytes. It will take up 4 bytes inside of your memory. Like I said, guys, again, we are here talking about how is data stored inside of our computer. So when I'm writing int a is equals to 4, it is actually creating a space inside of your memory, inside of your computer's memory, that is taking up 4 bytes of space, which actually stores this particular value 4 inside of it. Now this 4 is basically represented by a. So the value of a is being contained within this 4. Now, you need to understand this particular block of data that is present inside of the memory needs to be accessed. And this is where your address comes into picture. Each block of memory that you're ever going to create has its very own address by which we actually get to that particular location. This address can be anything. Let's look at it from a perspective of how does the address look like. Okay, so we will go back and we'll create a particular array. We'll create an array right over here, guys. Give me a second. We'll go to our particular C++ online compiler. We'll write our code right over here using name spacestd. We'll remove this std line from here. We'll write our code, guys. We'll create a particular array. Int arr is equals to 1 comma 2 comma 3 comma 4 comma 5. Okay. Okay. See out less than memory address of ARR. So here I'm basically checking where my array is starting. Okay, that is what I'm trying to check, guys. Where my array, okay, I have not closed the brackets. I don't know why I have not closed the brackets. Like I said, guys, here we are checking where is the memory of our address ARR, the particular array that we are creating. So let us draw it out, guys, so that you guys are able to understand. For example, if I'm creating an array, okay, if I'm creating an array ARR is equals to 1 comma 2 comma 3 comma 4 comma 5. So we know that the size of this particular array will be equal to 4 multiplied by 5, that is equals to 20 bytes. Are you guys able to understand this? The size of this particular array will be 4 bytes, that is the size of each of these elements, 4 bytes multiplied by 5 elements that are there, right? That is 20 bytes of space that will be occupied by this array itself. Are you guys able to understand this? Please let me know. This is not new. This is something that we have learned yesterday. This is something that we have learned yesterday. Now, inside of your memory, a space of 20 bytes will be created. A space of 20 bytes will be created, inside of which your elements will be present. Inside of which your elements will be present. That is 1, 2, 3, and so on and so forth. Now, the address at which this array starts can be got by using the AND operator. So we are writing AND ARR, that is pointing out to the address at which, the memory address at which the array exists inside of your computer. Where is this array stored inside of your computer? You can actually get that by writing AND ARR. That will get you the memory address of that particular array. Let us check that out practically as well. Right over here, I've created this particular memory address. Let us put that up, and ARR less than. Okay, let's stop right over here itself. That is what we will be printing, and we will run this out as well. As you're able to see, the memory address of ARR is coming up to be this particular value. Are you guys able to see this? Please let me know. Now, why am I teaching you guys this? Because at a later point of time, when we'll be learning about a new data structure called as linked list, this concept of memory allocation and all this will become very important for you guys. Understanding pointers is an integral part of any kind of programming language that you guys are going to learn. That's the reason why understanding this is going to be very important for you guys. So this is actually the actual address inside of the memory where your data is actually stored. This is where your data is actually stored inside of the memory itself, guys. Now, this value that you are able to get, this particular value that you are able to get, you can also create a pointer to this value. Okay, I want to create a variable. My aim is that I want to create a variable that stores this address within it. That is my aim. I want to create a variable. So I know that at some particular location inside of my memory, my array actually exists. So this is my array. Okay, this is my array 1, 2, 3, 4, and 5. At a particular location that is mentioned right over here 0x7ffc 0x7ffc5 dot 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 dot. At this particular address, my array exists. I want to create a variable that is able to store this address for me. Okay, so that is what pointers are. Think about pointers as a pointer. It is pointing to the address. Again, sorry. It is pointing to the address where your array is stored. So if I'm creating a pointer PTR, I'm creating a pointer PTR, it will actually store this particular address within it. Are you guys able to understand this? Please let me know. It will store this particular address within it, guys. Are you guys able to understand this? Please let me know. I'm creating a pointer. So a pointer is basically like a pointer, like a finger pointing to the address where my array is stored, or some other value. It points to the address of that particular value, guys. Creating a pointer is super simple. Now your array is of type integer, right? Your array contains integer type of data. So your pointer will also be of integer type itself, guys. Please do understand this. Why do we need it? We'll understand. Why do we need pointers? You will only be able to understand when we start the next particular data structure, guys. That is your particular, what do we call it as, linked lists. When we'll start with linked lists, you guys will be able to understand why do we require pointers. Right now we are learning what are pointers and how to create them. So like I said, guys, the array itself is made up of integers, so your pointer will also be of an integer type itself. Creating a pointer is very simple, just like int, star, and the name of the pointer. You can name it as anything. You can name it as Shaurya as well. You can name it as Chirag. You can name it as Space Explore. You can name it as Harsh. You whatever you want to name it as. But for our purpose, we are just naming it as PTR. Okay, is equals to ARR. That's it. That is how you create a pointer to this array. That is how you are able to create a pointer to this array, guys. So what is the data type of your array? Mention that. A star, that indicates you are creating a pointer. Name of the pointer and what it is pointing to. It is pointing to your array itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know. Yes, register memory is faster than cache memory, but again, your cache memory is still split into L1 and L2 memory. You are having your register memory. There is third type of memory that exists inside of the CPU as well. But we are not here to learn about the CPU architecture. We are just here to let you guys know that how the memory actually works. That is my major aim. This concept of pointers is much more important, right? Why int? Because the array is of type int. Your array is of type int. You're creating a pointer to that array. So depending upon what is the type of the object that you're using, so we are having an integer type object and we're creating a pointer to it, and the pointer is going to save that object, that is the integer array. Okay, that is what we are creating right over here. Let us try it out once again, guys. So we'll go back to main.cpp and we'll create a particular thing right over here, and L, and we'll create a pointer, guys. So int star ptr is equals to ARR. We created a pointer right over here, guys, and here we will be using that pointer. So see out less than memory memory DRES's address of ARR array less than PTR should be more than sufficient. Save. Oh, okay, we don't need to save. Output run. So as you're able to see, in both the cases, we are getting the exact same answer. So even if you're using that is and then ARR, you're getting the address. And even if you're using pointer, you're still getting the address. Now, learning about pointers is very important once again, because ever if you're going to learn about trees, graphs, going to learn about linked lists, these are other data structures and algorithms. The concept of pointer becomes very prevalent right over there. Even in some of the cases, there are some specialized algorithms that comes into place where the concept of pointers becomes very important. So understanding pointers and how to create them, how to use them is a very important task. Okay, do we use pointers? If you are ever going to go in depth into data structures and algorithms, you are ever going to learn it for your placements or for your internships, you will require it. That is the reason why I'm teaching it to you guys. Okay, are you guys able to understand this concept of pointer? Pointer basically points to the address. So array basically contains the values. Using your indexes, you are able to iterate through the values that are there in your arrays. Pointer points to the address at which your array is present. It points out to the address at which your array is present right over there, guys. That is what we are trying to do. Okay, are you guys able to understand this? Please let me know. No, so please try to understand this, guys. and %ARR is not a pointer, guys. It is just giving you the particular address at which array is stored. Pointer is a variable. Pointer is a variable that is currently pointing to the address of ARR. We can change it as well. We can create another array called as BRR, and we'll have another array right over here, 3, 4, 5, 6. I can change the pointer to point to BRR. I can just write PTR is equals to BRR and it's done. I can change the pointer to any particular address that I want. And ARR is just a constant value, that is just the just the address. We don't want just the address. We actually want a pointer right over there. Okay. Now, this concept of pointers will become very important in the future when you guys are moving further into the boot camp as well. That is the reason why I'm telling you guys this. Okay. Are you guys able to understand this? Please let me know. For those who are late in the class, I'll suggest to rewatch the video if you're not able to understand it. Okay. Okay. So let us go back and let us continue from right over here. The next thing that we are going to do is how can we use this pointers to traverse the array? Okay, how can we use this pointers to traverse the array? That is also a very important part. Now that we have created a pointer called as PTR, we'll use this to traverse the array, guys. So let us just do a cout first. Cout less than star PTR. Okay, star PTR. We'll run this off. So star PTR will give you the value. Okay, when you are creating a pointer, you are writing int star PTR is equals to ARR. That is how you are able to create a pointer pointing to the address at which the array is starting. Pointer pointing to the address at which the array is starting. If you want the value that is present at that particular address, if you want the value that is present at that address, that what is the value present as 0x7ffc5, what is the value present at that particular address, then that you can get it by writing star PTR. That value you can get back by writing star PTR. It will give you the value present at that pointer. So think about it in such a way that you are having a particular array right over here. Sorry, 1, 2, 3, 4, and 5. This is the pointer that we have created, PTR. This is the pointer that we have created. It is pointing to this particular address, that is 0x77f something something something. I don't really care about that, but that is the address that it is pointing to. If I want to get the value present at that address, I have to write star PTR. That will give me the value present at that particular address. Now, in a similar manner, if I want to get the value of the next address, I can just shift the pointer one step further. Shifting a pointer is very simple. You just have to write cout. Okay, so I'm just writing it down so that you guys are able to see. And L. Okay, cout less than. Shifting a pointer one step further is PTR plus 1. If I'm writing PTR plus 1, what is happening is the new pointer that I'm creating. I'll draw it out with the next particular color. So this will be the new pointer. This is PTR plus 1. If I want to shift it one further, PTR plus 2. This is PTR plus 3. This is PTR plus 4. So that is basically how you can shift your pointer further. Okay, how you can shift your pointer further. Now, if you want to get the value that is present within that particular address, what do you want to do? You would just have to put it inside of brackets. That is the pointer that you have created, and put up a star in front of it. That is how you get the value present at the new address, guys. That is how you create the get the value present at the new address. Guys, I'm able to understand that many of you guys will be thinking, why are we doing this? Why are we learning this? Please do not think that. Okay, you are learning a new thing. The reason why we are doing this, you will be able to understand once we start linked lists. The entire concept of linked list actually lies on the foundational knowledge of pointers. Without that, linked list, trees, graphs won't even exist. Most of your data structures and algorithms and computer programming won't even exist without pointers. Okay, it is very important to understand the concept of pointers, guys. Okay, are you guys able to understand how can we make our pointer go further? Okay, so right over here, guys, as you're able to see, if I put down my bracket parenthesis and then a star in front of it, and I put up a particular semicolon at the end, and I run this, as you're able to see, 1 and 2 are getting printed right over there, guys. 1 and 2 are getting printed right over there. In a similar manner, I can traverse the entire entire array itself, right? Using a for loop. For int I is equals to 1. Okay, I is equals to 0. I is less than the size of the array. So we'll need to get the size of the array, guys. So int n is equals to size of arr divided by size of arr0. That will get us the size, this is the number of elements in the array, guys. So we have to go less than n, right? Not equal to n. Again, n is the number of elements in the array. So how many indexes will be there? 0 to n minus 1, right? So we are going to go 1 less than n, and then I plus plus, and then we are going to do a cout, guys. So here we are going to do cout less than, we are going to have our okay, so your ptr plus I, and then in parenthesis we are going to put up our star right over here. Let's keep a little bit of value, less than a space, and I think so that should be it, right? Let us run this out and see how that goes on. Okay, I have misplaced a particular, okay, I'm very sorry for that, I was not able to see it properly. Okay, I think so now it is clear, right? I think so now it's clear. Let us run this up. As you're able to see, we are getting 1 2 3 4 5 getting printed without using indexes. We are directly using pointers, we are using addresses right over here, guys. Okay, what if you want the third index? So Ullas is asking, so I'm going to ask this question to you guys. If you want the third index, how are you going to print the third index? Okay, 0 1 2 3, third index using a pointer. Can somebody please let me know? Oh, very good question. After this, I will be answering Nikhil's question, guys. I will be answering Nikhil's question after that. Very good question, Nikhil. Can you guys let me know, first of all, if I want to access the third index, 0, 1, 2, 3. Third index, guys, not third element, third index. What will be the code for that? Guys, I'm trying to access the third index, not the third element. Please listen to the question once again very clearly and think about it. I'm trying to access the third index, not the third element, guys. Many of you guys are writing the wrong answer. Listen to it very clearly. So if the pointer points to the first zeroth element, okay, that is zero index, then this points to the first, then this points to the second. So third will be PTR plus 3. PTR plus 3, guys. Again, third index, not third element. Please do remember that very clearly. Okay. The next thing that you guys need to understand, a very good question. I forgot the name of the person who actually asked the question. I'm really very sorry. I'll just see if I'm able to find that question once again. I think so. His name, Nakul. Nakul Kumar has asked a very fantastic question. If all data has addresses, is there an address for a pointer also? Absolutely yes. So inside of the memory, actually, what is happening right over here is that when you're creating a pointer, okay, when you're first of all, you're having a particular array, right? This is your array right over here, which is getting stored inside of the memory. So it will look something like this. It won't look like this, guys. It'll actually look like this. This is how your array will be looking like. You will be having your address right over here, that is 07xff something something. That is the first address where your 1 is getting stored, then your 2, then your 3, then your 4, and then your 5. This is how your array is getting stored. There will be multiple other boxes as well somewhere down below. This is where your pointer is going to store. PTR is getting stored, guys, inside of which the value that will be present will be this particular value, that is 07xff something something will be stored, and the address of this particular box will be something different. It might be 06x cf dot or something like that. So even the pointer will have its own address, guys. That is how it is actually stored inside of the memory. Okay, this is actually the representation of that. Are you guys able to understand this? Please let me know. This is the actual representation of that, guys. And each of these boxes are going to occupy 4 bytes. Each of these boxes are going to occupy 4 bytes. Let us see that, guys. Let us see that in action right now. Maybe that might help you guys out with the same. Okay, let us see that in action. So let us take up PTR. Let us just print PTR, guys. So C out less than PTR less than end L, and we'll also print C out less than PTR plus 1. So I'm printing out the addresses of the pointer and the next element as well, guys, end L, and we will run this. So as you're able to see the difference, so what I'm printing right over here, guys, what I've printed right over here is the address for the first element and the second element, guys. I'm printing these two addresses. Okay, that is what I'm printing. This is PTR and this is PTR plus 1, guys. So I'm printing the addresses of the first two elements. As you're able to see, the difference between the address is actually just 4. If you guys see it very clearly, the difference between the address is actually just 4, guys. And this 4 is actually the particular like memory that the element is actually utilizing. That is 4 bytes. Are you guys able to see this? Please let me know. Are you guys able to understand this, guys? Please let me know. That is the size of the int, guys. And that is how you are able to see this pointer actually moving further. Plus 1 basically means going to the next element. Right? I know this might be interesting for some of you guys. I was actually very fascinated when I dived a little bit deeper in my college days into this particular topic, because these are very famous interview questions. Okay, these are something that is very famous. Pointers is one of the most important questions that actually gets asked in finance companies. So banking companies or finance companies, if you are going to join them as a software development engineer, especially into JP Morgan and Chase or Goldman Sachs or Morgan Stanley or American Express or MasterCard, these type of companies are very much interested into pointers. Even Microsoft, the most important part of a Microsoft interview is actually pointers. They ask a ton of questions in the Microsoft interviews related to pointers, and hence pointers has gained a lot of following as well. Learning pointers has become very crucial for you guys to do it properly at the end of the day. Doing it okay is fine, but doing it properly as well is very important. Are you guys able to understand this concept of pointers, guys, and these addresses that are there, how it is stored inside of the memory and all this? Please let me know. Are you guys able to understand this? Please let me know, guys. Huh? So why are you not giving attendance link for the last 2 classes? Guys, could you guys please let me know, have I not given you guys attendance link in the past 2 classes? Somebody is saying that I have not given attendance link in the past 2 classes, guys. Can you guys let me know if I have given you guys the attendance link or not in the past 2 classes? Please let me know, guys. I've given you guys, right? Every single class I gave you guys the attendance. Now, those students who come up late in the class, who are not paying attention in the class, of course, they will not be able to find attendance links, because that is, I don't know how that is my fault. But yeah, if you come here to learn, if you pay attention in the class, you come on time, you'll find the attendance link, because every day I'm taking up attendance, right? Great. That is the, like, I think so. That is also something that I've heard for like a millionth time up to this point of time, but in a very new format. Okay, no issues in that as well, guys. Okay, now that you guys are able to understand pointers, the next thing that we need to understand is multi-dimensional arrays. We will be talking about 2-dimensional arrays, guys. That is the major thing that I want to discuss with you, but there are multi-dimensional arrays as well. Now, what is a 2-dimensional array? Up till this point of time, the arrays that we have learned about is just one dimensional, right? It basically lives in only 1D. That is just a line, right? For example, this 1, 2, 3, 4, and 5. This is what we call as a one-dimensional array. Can you think about how can we create a two-dimensional array? An array which lives in two dimensions. That is this and this. This is how that array will look like. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is what we mean by a two-dimensional array, in which you are having both x and y axis. If you were ever studying about mathematics, I think so you guys will be able to understand that this is what you call as matrices, right? Two-dimensional matrices or matrices, whatever you guys used to call it. My English is not that great, so mispronunciation is something that I do regularly. Okay, but I hope that that is something that you guys are able to understand. Now, how to create these two-dimensional arrays inside of C++ is something that is of a crucial importance topic for you guys to understand in arrays as well. Now, creating that is actually pretty simple. If you're ever creating a one-dimensional matrix, what did you used to do? You just used to write the name of the array, then the size of the array, and then the particular you used to build your array itself. Now, if you think about it, what is a multi-dimensional array? Okay, if this is your one-dimensional array itself, let's assume 1, 2, and 3, and let's name it as 3 itself instead of 5. Think about how does a multi-dimensional array look like to you guys? Are you guys able to find any kind any kind of similarity between the two guys? Are you guys able to find any kind of similarity between a 1D array and a 2D array, guys? Could you guys please let me know? Think about it. Anything similar that you are able to see between the 1D array and the 2D array, guys? Any kind of similarity that you are able to see between the 1D array and the 2D array, guys? Does data science need to learn pointer if you want to get an internship or a placement? Then yes. But if you don't want an internship or a placement, then no. You are able to see that the two-dimensional array is nothing else but three separate one-dimensional array. You can create this as this: 1, 2, 3, 4, 5, 6, 7, 8, and 9. Your 2D array is just made up of three 1D array itself. And each of these arrays can be built like this. I can represent this same 1D array as this particular line, right? So I can represent this as 1, 2, 3. I can no, so sorry. Just pardon the brackets, guys. I moved to the very end. 4, 5, 6, and then 7, 8, 9, right? I can represent it as this. Can you guys agree with me on this particular fact? Can you guys agree with me on this particular fact? Yes. And now I can also represent this as a 1D array that is made up of where each of the element is actually a 1D array. I can represent this particular array, this bunch of arrays, as a collection of arrays, right? That there is a bigger array that contains each of these arrays as individual elements. So instead of having numbers or instead of having characters or strings as a particular element, we are having 1D arrays as a particular element, guys. Now, if 1D arrays are a particular element, if these are your elements, guys, if these are your elements, let's name it as X, Y, and Z. Let us name it as X, Y, and Z. So to create this particular 2D array, can I name it as, can I put it as X, Y, Z? Can I put it as X, Y, Z? And if I want to put this properly, then I will put it up as X value 1, 2, 3. Then you're having the Y value 3, 4, 5. And then I'm having the Z value that is say 7, 4, 5, 6. I'm so sorry. And then you are having your 7, 8, 9. That is the value of the Z. Are you guys able to understand how can I create this two-dimensional array, guys? Are you guys able to understand how I represented this two-dimensional array as a larger array of smaller one-dimensional array, guys? As a larger array of smaller one-dimensional array, guys. Now to create this, it is pretty simple. Okay, if I want to create this, it is actually pretty simple, guys. Name of the array, let us name it as ARR. Okay, 2D. Let us name it as ARR 2D, guys. Or we can even name it as ARR itself. That is up to you guys. Whatever you guys like to call it as, you guys can name it as. We'll call it as ARR itself. ARR. Then we have to specify the number of rows and columns that it contains. So always remember RC, remote controlled car. Okay, RC or remote controlled car, guys, where R means the number of rows that it has and C means the number of columns that it has. So for our example, guys, what are the number of rows and columns? For our example, guys, what are the number of rows and columns, guys? For our example, guys, what is the number of rows and columns? 3, 3, right? So we'll create it as ARR 3 and 3. That is 3 rows and 3 columns is equals to 1, 2, 3, right? Then 4, 5, 6. Then 7, 8, 9. That is how you create a two-dimensional array. And bigger array of smaller arrays. If you think about it in such a way, it will be easier for you guys to create an array. Now, how to access an element out of this array? That is also very important, guys. Okay. How to access this array? That is also very important, guys. Many of you guys face a problem in that. So let me draw the array right over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like I said, your normal one-dimensional array has indexes. In a similar manner, this two-dimensional array also has indexes. But that is indexes for both row as well as for column, guys. For both row and column, you will have indexes right over there. So 0, 1, 2, that is 0th column, 0th first column and the second column. In similar manner, 0th row, first row and the second row. Okay, that has the indexes. If you want this particular value, then you have to write ARR. What is the row number, guys, for 5? What is the row number of 5, guys? Could you guys please let me know? What is the row number of 5, guys? Could you guys please let me know? What is the row number of 5, guys? Row number of 5. This particular element that I've crossed out. What is the row number of that? 1, 1. Okay, first row and first column. This will give you the value that is 5. This will give you the value that is 5. If you want this particular value, that will be ARR. What is the row number? Row number is 2. What is the column number? 1. That will give you the value that is 8. That is how you can access values from your array. Let us see that inside of code right now, guys. We'll go back to our coding. And we'll code this out right over here. So we'll remove everything. Three comma 3 is equals to 1, 2, 3. Then you are having 4, 5, 6. Then you are having 7, 8, 9. Right? That will create your two-dimensional array. If you want to access a particular value, C out less than ARR 2, 1. Let us just print this particular one out. As you're able to see, we are getting 8 on our screen. We are getting 8 on our screen, guys. Now, what if I want to print all the elements present in my array? What if we want to print all the elements in my array? That is your homework. I've taught you everything up till this point of time. I want you guys to think about it. I'm having a two-dimensional array, same as this. I'm having this two-dimensional array, guys. I want to print 1, 2, 3, 4, 5, 6, 7, 8, 9. That is my aim. In one line, I want to print all the elements present in this two-dimensional array. What will be the exact code for that? I want you guys to prepare this code and bring in tomorrow's class. Even if you don't do this particular homework, guys, it's not my loss at the end of the day. It's yours. You are not able to grow. You are not able to learn anything further. It is your loss at the end of the day. Do you want to lose on just 10-15 minutes of a little bit of work? I don't think so, right? You have already invested so much time in these classes. Why not just give 10 more minutes? Right now, I'm ending the class a little bit early so that you are able to spend the next 10 minutes searching for how to print this. Try it out yourself, guys. I know you guys have the answer. Think about it. That, okay, if I want to print all the elements in my first row, I will just write, okay, ARR, okay, first row, zeroth column, first row, first column, first row, second column. Then I'm changing, okay, ARR, then what is the next thing that I'm printing? What is the thing that is changing right over there? When is it changing? Think about it, try to come up with a solution. A hint many people have already given right over there is called as nested loops. Those who have written that, I know they already know the answer. For those who don't, try it out. Okay, hint has also been given by the community and by me to you guys. You don't even have to apply a lot of brain. Hint has also been given to you guys. Try it out, figure out the solution and let me know. Kalyan Creations, yesterday you didn't send me that email. Could you please send me the email, Kalyan? I asked you to send me the information right over there on my email, Kalyan. I think so you have forgotten about it. Or else just let me know your name. I'll personally contact you. Kalyan, yesterday I told you to send me the email. I never received it. Nevertheless, if you are not able to send me the email, just let me know your complete name so I'm able to reach out to you and help you out right over there. Will you guys be able to do this homework? Please let me know. Will you guys be able to do this homework, guys? Please let me know. Lavya, I will make sure by tonight your particular problem is solved. Okay, Lavya, do not worry about that. And again, Kalyan, if you are able to provide me with your name, that will be amazing so that I'm able to get to the bottom of this as well. Okay, so now I'm going to give you guys the attendance right now. Or Kalyan, just email me. That would be much more better for me as well. Why is my phone buzzing? Okay, so this is day 4, I guess. Kalyan, if you are there in the class, could you please let me know your name so that I'm able to contact you? Okay, so this is the attendance link, guys. Please start filling the attendance link. The attendance link will be closed exactly at 9:10, guys. The attendance link will be closed exactly at 9:10. Please start filling up your attendance, guys. We'll meet in tomorrow's class at the same time and we'll continue from right over there. Thank you so much, guys. We'll meet in the same class tomorrow at the same time and we'll continue from right over there. Do not forget to complete your attendance as well as your assignment. You have time right now. Just do the assignment right now itself. Practice everything, guys. Okay. And just try to play around with it. Thank you so much, guys. Bye, guys. Bye bye. Bye bye. Bye bye.